Hello and welcome to Virtual SQL Bits event. My name is Mahesh Balija and I am a Senior Cloud Solution Architect at Microsoft. My specialization is into data, AI and IoT. I work closely with Microsoft partners and help them build solutions on Azure Cloud Platform. I have over a decade of experience in building and deploying big data solutions, which include not just data, data science, and artificial intelligence. In this session, I will talk about Azure Synapse Analytics, which is a recently announced service from Microsoft. I know there is a lot of excitement built around this technology. This is part of a two-part series. In this session, I'll be giving a high-level introduction of the service. And in the next session, which is on Saturday, I will give a real-world example along with a working demo. Thank you and welcome again. Hello and welcome back. My name is Mahesh Balija and I'm a Senior Cloud Solution Architect at Microsoft. In this session, I will do a high-level overview of Azure Synapse Analytics, followed by a quick tour around some of the key capabilities of Azure Synapse Analytics Workspace. Let's get started, folks. Without any doubt, analytics and AI is being one of the % top priority investments for many organizations and the business leaders. Statistics say 80% of the organizations today struggle to become matured data adopters. And one of the key reasons for that being data exists in disparate systems. And because data is in multiple siloed environments, it makes it quite hard for the organizations to be able to tap into the full potential of the data. In my experience, I've worked with various different industries such as banking, telcos, and few others. I have seen a common pattern, and the pattern is in 2010s, in the last decade, right? We have a new term coined data lakes. The whole idea behind the data lakes is basically for organizations to be able to pull the data from various different data sources. It could be a line of business applications, or third-party systems, or applications, and place all the data into a centralized data lake platform such as Hadoop, which is big data, and do the mass data processing on the big data platforms. Finally, integrate it with some MPP database so that you would have the ability to interactively build the reporting capabilities on top of these large data sets. One of the key challenges with this approach is because there are two different systems such as big data platforms and the MPP databases, it makes it quite hard for the organizations to be able to combine the power of these two technologies. And hence, we hear from you, right? So we introduced at Microsoft Limitless Analytics with Azure Synapse Analytics. By combining the power of both these platforms, now you have the ability to harness the data across different systems using Azure Synapse Analytics. Here is the quick definition about what is Azure Synapse Analytics. If I had to quickly pick a couple of key aspects out of this, one is unmatched time to insight. No matter where the data lives, whether it's on Azure Data Lake, or it's on Cosmos DB, or it's on the data warehouse itself, you can have the ability to work with all these disparate data sources in a single environment, and hence time to insight. Everything is possible at blazing fast. With the huge performance improvements, now Azure Synapse Analytics allows you to run large-scale queries at low latencies, such as you can process billions of records in millisecond latencies, provided if you have tuned the database in an appropriate manner. And what is really Azure Synapse Analytics? Some of you may be wondering, okay, is this just the SQL data warehouse on Azure? Yes. So it is the evolution of the SQL data warehouse, which combines both the power of the SQL data warehouse and the big data platforms and the Azure cloud platform. With a lot more richness and the ability to support various different roles in any data project, it becomes a natural fit for most of the modern data warehouse implementations on Azure. So let's talk about what is modern data warehouse and what is the typical architecture for any modern data warehouse implementation. You might have seen this slide, seen this architecture in various different contexts. From the modern data warehouse context, if you are building any data warehousing kind of solution, the first thing is to ingest the data from disparate data sources, such as line of business applications, ERP platforms, or even the operational databases, or even sometimes third-party systems as well, such as social media data. So data ingestion is the key. Once the data is ingested into your environment, you need to store the data. And once the data is stored, then you process the data and create a semantic layer so that you could serve for the reporting kind of requirements. From the Microsoft Azure standpoint, for data ingestion, you can use Azure Data Factory on the cloud. And for storage, you leverage on the Azure Data Lake, which is one of the powerful large-scale data platform, ability to load any kinds of data. And for transformation, you can leverage on various different technology stacks, such as you can use Azure Data Factory itself with its graphically inbuilt ETL capabilities. You can quickly drag and drop and create UI-based transformations. Alongside with Azure Databricks being a first-party service on Azure, you can build more complex transformations using Spark-like technology with Azure Databricks. And for serving layer, you leverage on the SQL data warehouse, now called as Azure Synapse Analytics. And for visualization, you leverage on the PowerBI. So that's a standard architecture on Azure Cloud Platform for building any modern data warehouse-like solutions. So to just simplify the previous architecture, you're just bringing in data from various different sources from Azure Data Factory, storing it in Data Lake storage, processing with Azure Databricks and the Data Factory, and serving it through Azure Synapse Analytics. For your BI kind of purposes using Power BI. Our grand vision is for 99% of the modern data warehouse implementations, we are simplifying the whole modern data warehouse implementation on Azure. Instead of working with various different tools and technologies and worrying about the cost and security and management of all those different services, now you can just leverage on Azure Synapse Analytics, one simple service, and have the ability for data integration, data processing through Spark, data warehousing with Azure Synapse itself, and visualizing it with Power BI. In fact, you can even build the Power BI reports natively within the Azure Synapse Analytics itself, which simplifies the complexity coming from these various different tools, especially in terms of pricing, in terms of security and management, the overall management. And it brings together various different roles for implementing any big data kind of solutions, any data warehousing solutions, such as data engineers, data scientists, data analysts, all can come together and work with a single technology, which is Azure Synapse Analytics. If you are building a modern data warehouse, for 99% of the scenarios, the answer is Azure Synapse Analytics. Let's take a detailed look at what Azure Synapse Analytics would look like. Right? Let's take a bottom-up approach and start with the Azure Data Lake storage in the bottom. Azure Data Lake storage helps you to load petabytes of data onto Azure Cloud Platform. And it helps you to work with any kinds of data, whether it's structured, semi-structured, or unstructured. You can just simply dump your data onto Azure Data Lake storage. With the enterprise-grade security, you would have the ability to encrypt the data while at rest. As well, you can configure the granular access control at the folder level for the users to access and manage the data. And with the common data model integration into Azure Data Lake storage, Microsoft have defined well-defined data models for specific industry verticals, such as financial services, telcos, and few other domains. The idea behind the common data model is very simple. You would have the set of entities and attributes associated with it, which would help you to be able to address most of the reporting sort of scenarios for specific industry verticals. And you can even harness the power of solution accelerators and work with the common data model quite efficiently. And common data model also comes quite handy, especially for the data integration sort of scenarios where various different applications are following the similar data model as well. So now that we have understood some of the key features of the common data model, if I take a step up, you can see the Synapse Analytics has the built-in data integration capabilities. All the Azure Data Factory related functionalities are now natively integrated into Azure Synapse Analytics, which you can use for creating and deploying the pipelines, creating transformations using the mapping data flows, and even for data movement kind of scenarios as well. And combining the power of both SQL and the big data technologies such as Spark, now if your data engineers are specialized in SQL, they can leverage with the SQL runtimes, which are also called as SQL pools in Synapse Analytics, and create and run the SQL queries to process the data. At the same time, your data engineers who are experts in the Spark-like technology, they can use Apache Spark and then build and run, develop and create their own transformations in the Spark framework. So both these platforms available as pre-provisioned compute, where you can predefine the amount of compute you need for the SQL pools and the Spark pools. And on demand, you can even run the queries as well. In on-demand mode, you would be charged by the amount of data being processed per query. And because Spark is natively supported, now you would have access to various different languages such as SQL, Python, .NET, Java, Scala, and R to work with the data living on Azure Data Lake storage, or databases such as Cosmos DB, or even the SQL data warehouse itself, which is on Azure Synapse. With Azure Synapse Analytics Studio on top, it acts like it behaves like an IDE, integrated development environment, where all these different roles come together and work on a single workspace. We'll see how this can be done when I run through a demo. And because all this unification of various different technologies, not just this, with the unification of Azure ML into Synapse and the Power BI capabilities, it makes it quite seamless for data management, security, monitoring, and Metastore-like capabilities to be built on Azure Synapse Analytics. Some key innovations on Azure Synapse include multiple clusters over shared data, the ability to scale out across various different SQL pools actually help you to create multiple Synapse clusters, and each would be dedicated for a different team. So you can have shared data across multiple clusters, which means you are not duplicating the data anymore, which would significantly improve the overall team's performance. Because the moment you duplicate the data, it would create a lot more, you need to deal with the data redundancy or data duplication or data synchronization sort of issues. With shared data having multiple clusters, all the different teams can leverage on the same data set without duplicating the data. With online scaling, you can now scale up as and when needed. Your queries which are already running on these Synapse clusters would not retire. They continue to run and they take advantage of the additional resources provision as part of the online scaling capability. With workload-aware query scheduling, you can efficiently manage which users would have priority over other users while running the queries. We'll go into the details of this scenario. And by combining the Spark and SQL integration runtimes, no matter what your skills and background is, you can effectively take advantage of various different technologies and work with the data coming from various different underlying platforms. With that, let's get into Azure Synapse Analytics Studio. Let's have a first look of how it looks. Let's have a quick look at how this Synapse Analytics Studio would look like. Here is the screen grab I have taken from the Synapse Analytics Studio, where you can see on the left hand side, you have the ability to work with various different aspects of your modern data warehouse, such as you can configure all the data sources underneath the data. Under the Develop Hub, you can now create the notebook scripts for Spark or even the SQL queries as well. You can even create the mapping data flows as well as part of the Develop Hub. From the Orchestrate Hub, you can now create and deploy the pipelines for the data using the data factory like UI within the Synapse Analytics. With monitor and management capabilities built into the Synapse Analytics Studio, it makes it so simplified to manage various different data sources, security, and all those aspects. And because Studio itself acts like an IDE, you can bring in data engineers, data scientists, IT professionals, data analysts, everything together into a single platform and work in a single environment, folks. Let's look into the data integration capabilities of Azure Synapse Analytics. So what is data integration? To give you a quick idea, let's talk about Azure Data Factory and its three key features. When you think about Azure Data Factory, there are three key things it performs. One, it is used for data movement kind of scenarios, where you can connect to any underlying data source within your on-premises environment or other cloud platforms and ingest the data into Azure Cloud Platform. So in the data movement scenario, you can leverage on Data Factory to process the data. With its recently announced mapping data flow capability, it gives you the ability to create and deploy UI-based transformations onto the cloud at scale. And last but not the least, it also allows you to create and deploy the pipelines. So what do I mean by pipeline and orchestration? Right? So when you work with any data warehousing like environment, you would end up creating ETL or ELT like jobs. There could be jobs which are part of the workflows, and these workflows needs to be managed by someone. When I say managed, the workloads needs to be orchestrated, like they needs to be scheduled like on an hourly basis or a daily basis or on a weekly basis. So Data Factory also takes care of orchestrating these workflows as well with its pipelines capability. I'd like to tell a very interesting story. I've been into a hack recently where the challenge was basically I had to write ETL jobs transformations using Spark. I have worked in big data industry over a decade now. I have written thousands of jobs both in native MapReduce and the Spark frameworks. And on the other hand, there is a business analyst, a data analyst. He was pretty much new to big data platforms. By the end of the day, I was just only able to create 2 transformations, while the data analyst who is new to the big data platforms, he was able to learn Data Factory and create and deploy at least 5 different transformations in a pipeline. So while with the caveat that Data Factory, you can implement the most commonly seen transformations like joining the datasets, transforming the datasets, such as parsing the records, or filtering the records, or aggregating the data as well. But for more complex scenarios, you should still have to leverage on Spark. But the idea behind the Data Factory is basically it improves the productivity of the data warehousing project significantly. So with combining the power of all these capabilities of Data Factory into Azure Synapse Analytics, you get all these features in Synapse Analytics, folks. With built-in 90 plus connectors within the Data Factory, instead of writing the code, you can just configure most of the popular databases as the source systems for Data Factory while ingesting the data onto the cloud. Here are some example kind of sources which are by default available within the Synapse Analytics now. For preparing under transformation, like I mentioned before, with the mapping data flow capabilities, you can create code-free or low-code or no-code kind of with low-code or no-code kind of technology using Azure Synapse Analytics, where you can quickly drag and drop few transformations and configure what exactly you want to achieve. As I mentioned, you can filter, join, aggregate the data quite efficiently with the UI-based transformations and deploy these transformations as pipelines using the Synapse Analytics. Moving on to the Spark. For those of you who are not familiar with Apache Spark, to give you a quick overview on how the technology would look like. So I generally treat Spark as a pluggable engine. The reason to say that is you can work with Spark and integrate it with various different underlying data platforms using technologies like Aeon or its own clustering capability, or a few others such as Mesos as well. However, the Spark core engine itself has got all the MapReduce like capabilities. You got specialized or domain specific languages built on top of the MapReduce capabilities of the Spark engine, such as Spark SQL, which allows the users to write SQL queries, which would then get translated into MapReduce jobs and get executed on top of Spark. Spark MLlib, it allows you to build and deploy large-scale machine learning algorithms and be able to build your intelligent models using Spark framework. With Spark streaming, you can process the data pretty much in near real time or even through micro batching capability as well. And last but not the least, you have the ability to work with the graph-like data structures using the Spark, where you can do more advanced or complex kind of analytics where the data has got relationships between each other, such as edges and nodes, are sometimes called vertices as well. You can build all those relationships and do complex analytics using graphics and the graph frames like capabilities as well. And moving on to some of the details of the Spark and how you can work with Spark within the Azure Synapse Analytics. Because Azure Synapse Analytics combines the power of Apache Spark, you can quickly create Spark pools from within its workspace and then use those Spark pools to create and deploy your Spark jobs. It's a very simple configuration. You just have to configure the name of this Spark pool within the Synapse Analytics and configure the type of nodes you want to be part of your driver and workers within your Spark cluster, and tell the number of nodes you need to process the data. And that's it. The Spark cluster would get provisioned, and then you have the ability to create your notebooks within the Synapse Analytics itself. When I show you the demo on how to create and deploy the notebooks using Synapse Analytics, it would then become crystal clear as well. Moving on to the SQL Analytics parts and some of the latest innovations happened within the Synapse itself. Let's have a quick look. With the Analytics Runtime, where you have the SQL, so users can write TSQL-like queries for various different scenarios, for batch transformations, streaming transformations, or even interactive data analytics you can leverage on the T-SQL-like environment. As mentioned before, with both provision and on-demand capability, you can now either pre-provision the compute and run your queries, or you can even run the queries on demand where you will be charged by the amount of data being processed for that query. With the best-in-class performance implemented in the Azure Synapse Analytics, folks, we have recently announced a key feature called as Result Set Cache. The idea behind the Result Set Cache is, imagine the data warehouses are closely integrated with the technologies such as PowerBI for business intelligence scenarios, where you have created the dashboards or visual analytics for your end users like business analysts or data analysts. So your dashboards could be accessed by thousands of users within an organization, where your queries are literally not changing. The first time when the dashboard is accessed by any user, the query gets executed and the results would be cached and persisted into the storage within the Azure Synapse Analytics itself. Allowing the next query onwards, the second read onwards, results to be accessed directly from the cache, being the most efficient way of serving the dashboards to the end users. And if the data is changed, it allows basically to kind of rebuild the cache as well. With the ability to pause and resume the data, the Synapse itself, your result set cache itself does not change, and automatically the cache would get evicted with least recently used algorithm as well. Here are some quick queries which you can see on the right hand side, which you can use to create to configure the result set caching on your Synapse SQL pools. Another enhancement was around the materialized views. By leveraging on the materialized views, you pre-compute these views and store the data. If the source tables changes, all those changes would be seamlessly replicated into your materialized views. With the incremental updates, it gives you a lot more power for working with the materialized views and improves the performance significantly as well. And with the ability now to work with the JSON datasets, you can just bring in the raw JSON dataset and dump it into your tables, and then query those JSON datasets with TSQL. As you can see, here is an example of how you can query the JSON dataset on top of the Synapse SQL pools. You can just persist the JSON datasets using the nvarchar data structure. Let's have a quick look at some of the workload management capabilities recently announced within the Synapse Analytics. With the scheduler, without any priority for the queries, this is how the queries would run. Let's imagine there are already preoccupied queries, and your C-level executive have actually is trying to analyze the sales data. Once the resources become available, then because of the first in first out, each user's query would then get highest priority. And over a period, your C-level queries have to wait, which is not a great experience for the top level management. With workload importance capability, now you can configure the priorities for each query, such as low, normal, or high. By configuring the C-level executives as highest priority, the moment the resources become available within the cluster, the C-level executive queries would then get executed. I mean, whoever the user has got the highest priority would get the precedence over other users, such as developers, for example. With workload isolation capability, now you can configure the ratio between two different teams. Let's say the same SQL pool cluster can be used across two different teams, such as sales and marketing. With the percentages being configured, if the marketing team is not fully taking advantage of your cluster, the sales can easily scale in and review and use the cluster resources most efficiently. And this would be even better for the billing sort of scenarios, right? It is because it's very clear that 60% of the resources are allocated to sales versus 40% is allocated to marketing. With the elastic scale capability, you can now scale up on demand without interrupting the queries running on the SQL data warehouse already. Such as you can go from 1000 CDWs, data warehousing units, to 2000 data warehousing units as per your workload demand without interrupting any of the existing queries. With scale out capability, you can even run multiple clusters on top of a single SQL data warehouse, allowing the different teams to be able to spin up and work with the data quite seamlessly. This is a powerful capability, both in terms of keeping the billing and pricing separate for the different teams and having the ability to work with the same shared data. Would reduce a lot of complications coming through the data duplication. So to summarize, you got workload isolation, where you kind of distributing the resources across multiple teams. Through scaling, you can efficiently make use of the resources when the resources are underutilized by the other team. With the elastic cluster capability, you can scale up quite efficiently. And with scale out, you can spin up multiple SQL clusters as well. And with the ability of parsing and resuming the clusters, you would only then provision the resources as and when is required. Not just the resource management capability. So you also have the ability to build and deploy the machine learning models natively within the Azure Synapse Analytics itself, and call those models as if they were functions as part of your SQL query. For example, you can use technologies such as PyTorch or ML.NET, TensorFlow, and build your machine learning model, deploy into SQL Analytics, and then make it available as if it's a function. As you can see, a sample query in the bottom of this slide, where I'm invoking a predict function passing the model name and the dataset, which would then score all the dataset right where the data lives within the SQL Synapse Analytics natively. Right. Moving on to the next part. So far we have seen how to process the data in batch. You also have the ability to process the data in real time using the streaming technologies as well. Such as on Azure, you got event hubs, which allows you to seamlessly ingest the data in real time from your applications. And with IoT Hub, you can even ingest the logs coming from your devices, Internet of Things devices. All of them can go through Azure Streaming Analytics, and then Azure Streaming Analytics job can process the data directly into the data warehouse itself. So having the ability to process the streaming data using the Azure Synapse Analytics, you can process batch and streaming data both. And with some Azure Advisor recommendations, now the service would recommend some of the performance optimizations on the database over a period based upon the type of the queries you are running on top of the database, such as reducing the data movement through shuffle by replicating the tables to address various different queries, or by properly distributing the data with new hash distribution schemes, allowing the queries to run at lower latencies, by recommending some cache related stuff, or even other capabilities as well, as you can see. So you have the choice to work with various different developer tools with Azure Synapse Analytics. My preference would be for the Visual Studio Code. However, you got the online available IDE, which is the Azure Synapse Analytics Studio itself. Right? And you can even work with the Visual Studio with SSDT plugin, or Azure Data Studio or SQL Server Management Studio to work with the Azure Synapse Analytics. So depending upon your preference or your experience, you can choose any of these developer tools to work with the Synapse Analytics. Not just that, now that most of you are familiar with the Power BI, Power BI being one of the popular technologies for visualizing the data and for your business analytics scenarios, you can now use Azure Synapse Analytics, create your reports natively within the Synapse Analytics itself, and publish those reports into Power BI service. So you can visually interrogate the data from within the Synapse Analytics itself and create those data sets, data models, and then publish those reports into the Power BI service, so where you're making your reports available to thousands of users within your organization. Last but not the least, which is Azure Data Share, is another new service which allows you to efficiently share the data from various different data sources within Azure tenant into other Azure tenants. Think about scenarios where you want to share the data with your customers, with your partners, to help build the solutions. You can seamlessly share the data without worrying about the underlying infrastructure, and just simply through some clicks, you can be able to efficiently share the data and can be able to manage the metadata quite effectively, such as who has access to my data, what frequency the data is accessed by the different customers and partners, what are the access policies. So you can define all those access policies efficiently and then share the data as well. And one of the key compelling capabilities of the data share is having the ability to share the data right in place. So data physically does not move into the other tenant, rather your other users can access the data on demand from within your tenant itself. Here is the comprehensive kind of architectural diagram, including the data share as well. Let's take a quick look for a couple of seconds and then I will move on. And security, Synapse Analytics being the enterprise grade platform, you got enterprise grade security as well built into the Azure Synapse Analytics. Such as with threat protection, it could automatically detect any vulnerabilities by interrogating the data for any anomalies within the system. and then recommending those anomalies to you. With the network security, you can safeguard your data not to be accessed outside of your virtual networks. With granular authentication and authorization, you can allow the users, you can configure the granular access control for the users and what they can do with the dataset and who can access the data with Azure Active Directory. You can encrypt the data both at rest and in transit, allowing the other third-party other applications not to be able to tap into your data. So now that we have understood the power of Azure Synapse Analytics, literally imagine any scenario while building a modern data warehouse solution, such as data integration, or data processing, or machine learning, or business intelligence. No matter what your scenario is, you can basically work with one single technology, which is Azure Synapse Analytics, and bring in all different roles such as data engineers, data analysts, data scientists, and even operational engineers as well. Everyone into a single platform, which is Azure Synapse Analytics. Hence, I like to call Azure Synapse Analytics, basically, in order to work with Azure Synapse Analytics, you need to coin a new term called as data genius, because you have access to every different technology within one single platform. With that, let's jump onto a quick tour around the Azure Synapse Analytics, folks. Folks, let's get started with the demo now. I have logged into portal.azure.com and I have created the Azure Synapse Workspace. Once the workspace creation has been completed, you can select the service. You would end up onto this overview section. If you want to launch the workspace, you need to select the workspace web URL underneath this overview section. It would then launch the Synapse Workspace. Before going into the Synapse Workspace itself, let's look into some of the additional nuances as well, such as how to create both the SQL pools and the Spark pools from within the Azure portal. If I'm selecting the SQL pools, I can see already the existing SQL pools as part of this Synapse Analytics Workspace. I can click Create New and I can give a SQL pool name, select the performance level such as TW units I need as part of this SQL pool cluster, and I can also see the amount of pricing charged for this particular pool, and click Create Review and Create. Similarly, I can go on to the Apache Spark pools as well. I can click New. Underneath that, I need to give the Spark pool name and the number of nodes I need as part of this cluster and the type of the node as well. Okay, here you would key in the Spark pool name. You select the type of the node such as small, medium, and large as of now, and then the number of nodes, which would be part of your cluster for both driver and the workers. And then click Review and Create. This would launch a SQL Spark pool as well. Now that I have logged into the Synapse Workspace, this is how the Synapse Workspace would look like, where you can see there are in the home page you have various tabs such as Ingest, Explore, Analyze, and Visualize. For example, if I select Ingest, it gives me a screen where I can go and quickly create a new connection. Okay, for example, I can go and select the connection button here and select whether I want to create a new Azure database. For example, by clicking the Create New Connection, I will then have the ability to select what is my data source, to ingest the data from that data source into Azure Cloud Platform, into Azure Data Lake, for example, right? For instance, if I search for SAP or Oracle, So you can find all the popular databases as part of this ingestion service. Once you configure the connection and test the service, then you can have the ability to basically go and create the pipelines. Let's have a quick peek into the data hub. Underneath the data hub, under the workspace, I can see various databases such as the Azure Synapse SQL Data Warehouse SQL pools itself, or even the Cosmos DB or other data lake storages as well. Underneath the link service, as you can see here, I got Azure Cosmos DB and the data lake storage accounts. I can configure multiple different data lake storage accounts as well, and I can even have some integration datasets as well. Okay, so now that we have seen how to access the databases and access the various different data sources from within the data hub, let's move on to the SQL develop hub. Underneath the develop hub, you got various different capabilities, such as you can create SQL scripts. Let's go on to the SQL script and let me quickly run a SQL query. I'm selecting I have already created few queries before coming to the session in the interest of time. As you can see underneath in this SQL script, I have written a query to basically get the count of the records from a table, sales table. It has instantly come back to me with the result, which has got 30 billion records within milliseconds, right? And then I have written a complex query as well, as you can see this one, which does lots of inner joins and aggregations. Let's see how much time this complex query will take on 30 billion records. It has pretty much returned the results to me instantaneously. For the very first time when I have run this query, it has taken roughly about 5 to 6 seconds. But as you could imagine, because the results are cached now, it has just returned those results instantaneously. And underneath the notebooks, I can basically create this Spark-based transformations within the notebook-like environment. I have created these notebooks where basically I am creating a predictive model using Azure machine learning AutoML capability, which would basically automatically find out the best suitable model for the given problem statement and create a model for me. So this particular notebook demonstrates the power of both AzureML, Spark, and having the ability to work with the datasets coming as part of the Synapse Analytics itself. And apart from the notebooks, I got data flows, which are mapping data flows, which are part of the data integration within Azure Synapse Analytics. If I select one of the data flows quickly, these are the UI-based transformations which I have highlighted before. The first transformation is basically coming from the pipeline which I have created as part of the pipelines, which I'll show you in a minute. I selected the pipeline name, which is data from SAP HANA. So the idea is to basically connect to the SAP HANA as the source and then load the data into Azure Data Lake Storage. While we are loading the data into Azure Data Lake Storage, we're also performing loads of transformation on that. For example, I'm filtering the last 5 years worth data from the source table. I'm also adding one more transformation, which would then create a derived column from the existing dataset. To give you a quick idea on what kind of transformations exist today within the data factory of Azure Synapse Analytics, as you can see, you can kind of perform the joins, conditional splits exists, unification of the data, or even lookups of the data as well. On top of it, various aggregate functions are also part of this as well, such as filtering, sorting, aggregating the records as well, which are out of the box capabilities. And could solve most of the commonly seen data integrations out of scenarios for building data warehouses. Apart from the data flows themselves, we also have the pipeline capabilities as well, okay, which are part of the Orchestrate Hub. Before going to the pipelines, I'd like to show you the Power BI capabilities as well, which are part of this Develop Hub. Again, I can see the Power BI datasets. I can even quickly go ahead and create my own reports as well, which is again part of the Synapse Analytics. Once I create a new report with few visuals, then I can actually publish that report back into the Azure Power BI service as well. And if I'm going into the Orchestrate Hub, I'd like to show you quickly a sample pipeline, let's say Azure Migration Integration, in which case I can show you how I'm basically integrating the data as well. Let's take another example here. Let's say SAP HANA to ADLS, the copy data activity, in which, as you can see, I've selected the name of this activity, source, where I've configured the source dataset, and this is the query which would then connect to SAP HANA to that specific table and retrieve the data, and so on. The sync being the Azure Data Lake Storage, it will create a file on the Azure Data Lake Storage platform. Okay. And not just having the ability to work with the databases, datasets on the Data Lake Store, or even Cosmos DB, ability to work, create your own notebooks, SQL scripts, or Power BI reports, ability to create the mapping data flows and the pipelines. You can also monitor these workflows as well, these pipelines, as part of this Monitor Hub. If there are any previously executed pipelines, those will be visible to you here. If any of the pipeline is failed for some reason, you could go and check what are the root causes for the failure of that pipeline as well. And last but not the least, you can even manage all these different resources which are part of the Azure Synapse Analytics as well, folks. So in short, or in summary, this Azure Synapse Analytics combines various different capabilities into a single platform, making it a powerful technology to implement modern data warehouses, and gives you the ability to work with any kind of data set on many different data sources. Thank you, folks. I hope you enjoyed this session. As a follow-up session, I'll be running a deep dive demo with a real world customer example. See you on Saturday, folks. Thank you.